Welcome to problem 3 in the week 5 spreadsheet. In the first problem parts of the spreadsheet, problem 1, we calculated, we found x, and then we found y. And in problem 2, we found the mean and the variance and the standard deviation and the covariance using matrix multiplication. And now what we're going to do is we're going to derive, from those two efficient portfolios, we're going to derive the entire efficient frontier by combining those two portfolios. The first thing we need to do is we need to use a two-asset portfolio approach to combine those two portfolios X and Y. If we do that, we can see that all we're doing is we're multiplying the return of X by its weight here and the return of Y by its weight here to calculate the return of the two-asset portfolio. And likewise, we're using the two-asset portfolio standard deviation or variance calculation. We're calculating the return or the weight of X by its weight, by its variance, the weight of Y squared by its variance, and then 2 times the weight of X, the weight of Y, and the covariance. Next, what we do is we need to graph various proportions of X to find the entire efficient frontier by combining X and Y together. And we're going to use a data table. And the first thing we have to do is we have to put in variance calculation in the top and put in expected return calculation there. And then we need to highlight the entire data table like so. Go to Data, What If Analysis, Data Table, and we need to put in the column the proportion of X, hit OK, and we can see if we do that we get the proportion, if we have negative 0.4, if we're short 0.4 of X and have a long 1.4 of Y, this is our expected standard deviation and our expected return, and we do all that from negative 0.4 all the way to 1.6, and we get these corresponding values, and if we graph it, we can see we get this nice efficient frontier, which is what we expect. Okay, that's it. Thanks for your time.